As part of my ENG600 project, I've decided to move away from a breadboard design and more towards a printed circuit board design. And the reason I've done that is because it makes it more appealing for potential buyers, it looks more professional and robust, and allows me to create in effect a shield which should plug into the FPGA with an LCD screen and a bidirectional logic level converter that will be able to plug into that shield, and that will all be contained within a rapid prototyped or 3D printed container. Okay, this morning I've created a design already, and I'll just walk you through what I've done to do that design. So I'll just open up the ISIS parenthesis schematic capture software package, which I'll use to create my design. Open up my saved design. Okay, now this design was created in two different stages. One stage deals with the PS2 connection, which is the top stage, and the signal condition of the logic level converter, which is this section here. And the bottom stage was completed for the LCD screen and the FPGA board. So I'll just quickly talk you through the top stage at current. So on the right hand side you've got a power bank, which is a standard power bank that's situated on the FPGA. Number 1 is ground, number 2 I'm not using for this project, number 3 is 3.3 volts, and number 4 is 5 volts. PS2 clock and data lines, these will be the lines that will be going into the FPGA, so they have to be at 3.3 volts. Okay, here's the bidirectional logic level converter. As you can see, I'm taking off 2 of the 4 possible data lines, so 1 and 2, 5 and 6 are the possible data lines. Well, I'm taking off 1 and 2, and they'll be going down into the actual FPGA. I've got 3.3 volts on pin 3, and I've got a ground on pin 4. So this side is the FPGA side. The PS2 connection side is on the other side, and that's at 5 volts on pin 3, and that's ground on pin 4. And here's the PS2 connection, and this will be where the keyboard wedge actually gets plugged into the shield in effect. Okay, that's the top half of the design. Now the bottom half is the LCD screen. This side here on the extreme right, what I'm circling with my mouse, will be what the LCD screen plugs into. Immediately to its left, this will be the corresponding pins of the LCD screen, but they'll be going into the FPGA board. To the left of that, I've got the standard power bank, starting off with ground at pin 1, and pin 4 is 5 volts. And I'm only going to use 5 volts for the LCD screen. And to the left of that, I've got the potentiometer, which will give me the ability to adjust the contrast, which is a 10K variable potentiometer. Okay, these are now translated through the netlist, and I've come up with this sort of design. It was important to measure where the pins were going into the FPGA to ensure that they line up correctly. And if you recall, it'll be these set of pins here, which are plugged into the FPGA, and these pins here. So the spacings from that pin and that pin to that pin and that pin will have to correspond to the spacings on the FPGA. For example, the spacing from here, that lower pin, to that pin, up to this power bank, and to that pin, will have to be exactly measured correctly on my design, or the shield won't fit. Okay, I'll just quickly talk through how this is connected. So you've got PS2 connection there, which will be roughly on the FPGA. It'll fit just above these pins here, so it'll be in this blank space there. Okay, the bidirectional logic level converter, which will be this section here, that will sit on the shield, and it should sit roughly here, just above the crystal oscillator. Okay, this is the PS2 clock and data line, those 2 pins, and that's the power bank at the bottom, and that relates to the FPGA. To the lower power bank, if you can make that out, which is there, and you've got a wing C, you've got pin 0 and pin 1, and that'll be where the clock and data fits in. Potentiometer, that should in theory sit just here on the shield. And then you've got the LCD screen, which will plug into a row of connectors, and you've also got a row of pins which will fit into the power bank and the FPGA board. And I'm going to use the bottom of the power bank, the left hand side power bank, as you can look at it now, and I'm going to use wing B for the LCD display pins. So that will fit in the second row down, well, the second data row down, which is wing B. So you've got wing A, wing B, wing C. I'm going to use wing B, and that's how the shield will plug in. So to give you a better idea of how that will look, if I change the view into a 3D visualization, I'll take the components off. So that's how it should fit. And there's this FPGA in comparison. And if you rotate, you'll be able to see where I've put the tracks, all the individual tracks which connect each pin. It's only a single layer PCB. And then on this section here, because it's single layer, I need to put a shorting link from this pin to that pin, which will be my ground. So the ground will come up, and I need a shorting link to go over, because it was impossible to route it around with a bidirectional logic level converter. Okay, so if you rotate that round again, as you can see, it's all labelled up correctly, as you'd expect. If I put the components back in, you get to sort of see a picture, more of a holistic design approach of how I created this. Okay, if we take those components out, okay, so that's my design for the printed circuit board. The next step now is to get the circuit board actually printed, then solder on the sills and the connections, and also the variable resistor, and make sure it fits actually over my FPGA.